Hey, I'm Thomas and this is day 24 of 100 Days of Code in IoT Challenge. Today I'm gonna show you how to simplify HTTPS communication between ESP8266 and the internet. And I'm gonna make it in a way that the browsers verify SSL certificates. And for ESP8266, what we're gonna have to do is to download a certificate store, which is really a list of certificates trusted by the browsers, and then upload it to device's flash memory. So this can be used with bare SSL client. But yeah, let's move to the code and I'm gonna show you the solution. So let's start from creating a new project with PlatformIO. So going to PlatformIO Quick Access, open, then new project. And I'm going to call it CertStore. The board is gonna be Node MCU. Framework Arduino, location default, finish. Cool, we've got our project created. Okay, first we're going to focus on the PlatformIO.ini. I'm gonna set the monitor speed. We're gonna need this to allow for the serial communication between the board and the IDE. And the second option is gonna be board build.filesystem equals little, I can just do little fs like that, right? So that changes the default file system from spiffs to little fs, which is faster, and it's essentially better for ESP8266 and ESP32. If you would like to know more about the differences between file systems, have a look at another video I have done on the file system itself, the link in the description. Okay, so that's the PlatformIO.ini configuration. Now I'm gonna go to src, and in the setup function, I'm gonna initialize serial communication. So that's essentially gonna be the baud rate that I set the monitor speed to, and a small delay for our serial monitor here to be able to catch up with the serial communication coming from the board. Okay, I'm gonna remove this comment from the loop function. And yeah, that's it for the initial setup. Now the dependency actually. So what we need to do is to install the core library I created during one of my previous refactoring sessions. So I'm gonna go to the lib directory, and I'm gonna clone the ESP8266 lib core repository that I've created with my core library, and I'm cloning it into a core directory. So yeah, I'm gonna put this command in the description of the video, so if you want to do it yourself, you can just copy paste this command. However, because today we're gonna be working with the first really with the single host HTTPS client, because that's gonna be our base to create the proper HTTPS client. I'm gonna have to check out change branch to day 20. That was the last time. Sorry, I need to go to the core first. So we need to go to the core and then do the checkout to day 20. Day 20 was me downloading the files from the internet using HTTPSClient, and I changed the response struct. I can even show you. So gonna give you a quick reminder, or for those who haven't watched that video, let me just quickly show. So previously the body was just a C string, but because the video 20 was about downloading the files, the bigger files as well, exceeding the amount of RAM memory on the microcontroller, I turned the body into a body stream, which really follows the basic stream interface, the abstract one, right? That is used with the files as well. So we've got available method and read bytes, write. I actually realized there is one missing, which is read string. We should also have read string, and that should just return this Wi-Fi client read string. So that will be useful for the smaller payloads on the response. Okay. So yeah. Anyway. So yeah, we've got the dependencies downloaded, and now let me open an example on Arduino IDE. Let me show you which one is this. If you go to File Examples and ESP8266 Wi-Fi, and the very first one, the CertStore, this is the example we're gonna be working with. Just few lines of code really that I'm gonna copy from here. But let me just quickly walk you through it. It is more or less explained here. So yeah, first of all, if this is gonna be about self-signed certificate, the CertStore is not the example we should go for. But this is not our case. We really want to be able to access any trusted, secure location on the internet, right? Any trusted URL. Right, and this section is actually talking about it, right? So that's how the browsers verify the SSL connections, right? They have a certificate store with the list of the trusted certificates. I think it's around 100 of them. This is like what it says, but yeah, for the Mozilla one, there's gonna be a script we're gonna use. Assets from Mozilla, we're gonna use those certificates. I think it's around 100 of certificates. And once you download it, you're gonna make and use this certificate store example. We're gonna make our ESP8266 behaving like a browser, like on the verification of certificate is gonna be like the browser, right? So if you remember, as a single host HTTPS client, right? So we had a domain. I tried to make a request to. And before that, I had to download a PM certificate and add it to the sketch, right? So the code could verify it. Same thing happens here, but using file system, right? We can upload all of those certificates, a certificate list, to a device's flash memory. And then, depending on the domain we're trying to access, it will be able to locate the certificate that needs to be used in the validation process. Okay. So yeah. So now, what I'm gonna do is to move to that sets from Mozilla PY. So this is really a Python script. So to be able to run this, you need to have a Python installed. There are some issues on Mac with that I've had. So I've decided to put this inside the Docker container. I created a Docker container. Let me just quickly show you. So that is this one, sets from Mozilla So with this Docker container, you can do it on any operating system as long as you have Docker installed. So if you haven't Docker installed, have a look at the description of this video. There is a link to instructions. You can also check on YouTube. There is a bunch of videos with the instructions. So yeah, it is anyway, Docker is installed on my machine. And to download all of those certificates, this is really a matter of running this script. So I'm gonna copy that line. And now we're going to move back to Visual Studio Code. Okay, because before I run this script, I need to create a data folder that is required to upload a file system image, to upload the files to ESP8266 from the computer, from IDE. Right, so I've got data folder, and now I need to change directory to that folder. So we're gonna go to data, okay, and I've already copied the command, so that's what needs to be done, right? Let's download it. It's gonna take a second. Okay, so we've got this, and that should produce a single file called certs.ar, right? So this is our certificate store. So I'm gonna change directory back to the CertStore, and yeah, this is it for downloading them. But now we need to upload them to the board. So yeah, first of all, make sure the board is connected to USB to your computer, and then what we need to do is to go to PlatformIO Quick Access, and then from the project tasks, Node MCU v2 platform, we want to click on Upload File System Image. And that is gonna connect to the board and upload our certificate store. Okay, so this part is done. We've got it uploaded. And the next step is going to be going to lib directory to our core library. And what I could do, I could just refactor this file, this class, but because I don't want to spend too much time on it right now, we'll have a separate video, separate refactoring session. And today I'm just gonna copy paste entire class, entire file, and I'm gonna rename the copy to just HTTPSClient. So that's gonna be HTTPSClient, not HTTPSClient copy. And that's gonna be class we're gonna be working on. Okay. So yes, I'm gonna keep most of the functionality here. So response is still gonna be response is still gonna contain a body stream. One thing I would like to do is to extract those outside, because at some point, I think during the next refactoring session, I'm actually going to create a namespace for this library, and we'll have, you know, structs like request response, like HTTP method that I'm going to introduce in a second, just, you know, put inside this namespace. Okay, yeah, I need to rename the HTTPSClient, the single host HTTPSClient to HTTPSClient, and there is few things we don't really need here. So host and PM cert, we don't need that. We're not gonna be working with them. We will have a certificate store instead, and this is gonna change also for for this, right? So this is not really gonna be the case anymore. We'll call another method, a different method on client. That method is called, I'm gonna show you, this is called CertStore, and that requires CertStore object, a pointer to it. So I'm gonna create it as a dependency. So we have something like, yeah, I need to include it though. So that will be CertStore bare SSL header file needs to be included, and then CertStore is the one that we're going to take a pointer. We're just gonna take a pointer and I'm going to put it as a private class member. Okay, and now with this we can easily set the CertStore on bare SSL on the Wi-Fi client secure. Okay, this is essentially it on the setting the CertStore. You can have a look at this example. That's how they do it. How they do it here. So we initialize the CertStore, right? Create the Wi-Fi client secure and set that CertStore on the Wi-Fi client secure. Okay, I think this is it on this example on bare SSL. However, yes, we need this bit. We need this bit. I'm gonna copy paste it into main.cpp setup function, right? Because we need to initialize the certificate store, and the certificate store, however, and the certificate store also needs to be initialized. And put on stack. So we've got certificate store. We're not gonna use spiffs. That will be little fs. So that's also gonna be little fs. Do we really need that information? I don't think so. We don't need that information. We just want to know what is the number of the CA certificates read from that file, and I think this is it. Okay, this is not it. We need to initialize file system as well. Otherwise, it won't be able to read those certificates from the file we uploaded to ESP8266. Okay. So that's the part to read the certificates, to initialize the certificate store. And you know what? Let me just quickly deploy it, and we should see what is the number of the certificates in the serial monitor. Okay, that's deployed, and we should see it in the serial monitor. Yeah, there we go. So number of CA certs read, it's 141, right? So currently Firefox keeps 141 certificates in its store. And yeah, let's disconnect from the serial monitor and go back to HTTPSClient. Right, so that would work, that essentially would work right now, but because the base code for that was a single host HTTPS client, there is still some things that we need to change, right? We don't have a host anymore. We don't have a host, and ideally, what we would like to do is to take that host in the send request, right? Because now we want to allow for the call to any host, right? Any domain, as long as it's trusted, but that's gonna be verified by the bare SSL. we should be able to make a request from ESP8266 to that host, to that domain. So that's one thing that is gonna be removed. And is there other thing? I think this is it. No, there's not really any other thing. Okay, so so my idea is to, let's make it more functional. Entire HTTPS client. So we're gonna look at the request struct. At the moment, it's very primitive. It just has path, right? With the single host, it was just the path that was really needed for the basic functionality. Because, we still couldn't take headers. We couldn't take request body, for example, if we wanted to make a post request with the JSON. And yeah, actually, we couldn't even take a method, right? It only accepts get, as far as I remember, right? We have just HTTP get. So let's make it more functional again, and let's add all of those properties of the request. Okay, so we will have path. We need a host, or I'm actually gonna call it a base URL. So base URL is gonna be the actual host. Then the path. The difference though, I'm thinking more about like the full URL, right? So like HTTPS and domain.com, something like that. So that'll be base URL. Path is gonna be what is after like com or .co.uk. So this is a path, right? So that's gonna be path. Right, this bit, this is gonna be path. I'm actually gonna set a default value, which is gonna be just slash. So that's the default path, the base path. Then another thing is gonna be the method. However, for the method, I remember from the server, that was web server. From the web server, you probably remember there was something like HTTP method. So let me just click through, and that's enum. You know what? I'm gonna use a very similar enum, so that'd be faster. We don't need web server here. Yeah, I just needed this to access that enum, and I'm gonna paste it here. However, I'm gonna remove any, because we're not gonna really accept that, right? From the client point of view, you are supposed to provide a correct HTTP method. So method is another one. Let's call it HTTP method, and that's just gonna be method. And then body. So body, ideally body would be a body stream as well, or actually not body stream. I'm not sure if body stream would work, because that stream is really a read stream. What we need is a write stream. So for now, that's gonna be a const char, a C string. And the next refactoring session, I'm gonna make it a stream, because yeah, I don't want to spend too much time on it. So body, and we also need headers. Headers, I'm just gonna use vector. So we have vector of std pair of 2 const char. Right, so that's our header name and value. And let's call it headers. So that is more or less complete request struct, except for the body, which is not a stream at the moment. So the amount of data we can send on the request is going to be limited for now, but that's okay in our case, in this example that we're working on today. So request is done. And let me just read all of this data from the request. Yeah, another thing, because it's grown in size, I think it would be better to take a pointer here instead of do the copy of the request. But yeah, I'm also gonna think about this later. So let's just take a copy for now. Okay. Right. So URL. So URL, we're not really gonna force the user to go for HTTPS. What I'm gonna do now is we really care about we still care about the path, but not protocol. And here I'm just gonna check the length of the base URL, and then we're gonna do str copy on the with the base URL. So that's gonna be the beginning, the base URL. Then we have request path, and that concludes it. I'm just thinking also another functionality that could be added to the request is the query string, right? Again, not gonna do it now because that can be just, you know, taken in a path. We could have path like, you know, A equals B and so on, right? We could do it as a path now, but in the future that could be another feature, right? To be able to like manipulate the query string from the request. So maybe I turn it into a class and add some methods. Okay, but let's go back to HTTP client. So now, yeah, so we prepared the URL that we're going to call. Then, because this is not gonna be just get anymore, I'm gonna change that. And yeah, this is the moment we need to transform this enum value into an actual C string, right? Because at the moment these are just you know 0, 1, 2, 3, 4. So I'm gonna create a private method, and because this one is really straightforward, I've done it already off the camera. So let me just paste it in and quickly go through it. Yeah. So read method takes method and the method value. That's gonna be the char that this writes to. And we have just a switch case here, right? So that checks like if it's options, then it's gonna copy options to that char pointer, and that's it, right? And then delete, patch, put, post, head, and the default one is just get. So that's what it does. So let's just read that method now. So in here around the URL, what we want to do, maybe here actually. Maybe here, once the connection is established, let's just define a char for the method. The length of the char, I think we can put something like, maybe we put 10. So it'll be 10. And then we just do this read method, and we pass request.method and method, right? So that's gonna write to the method variable, and we should get the method the method C string, right? Which I'm gonna pass here, right? So so the serial is gonna print out the method and the URL. Then I'm gonna modify this line because again that's not gonna be get anymore. I think what we are supposed to do is to run a send request. Yeah, send request that takes const char type. This is our method, and the second argument is the payload string. So what I'm gonna do is to do string request dot body, right? That should handle it, right? If the body is empty, it's also gonna handle it. If it's not, then obviously it's gonna send that body, right? That line is gonna be modified when I during the next refactoring session, or maybe actually the next example on the file upload. Maybe the next example on the file upload, I'm gonna have to modify this. Fortunately, send request, there are 3 overloads in total, and there is one that accepts stream, right? So we will be able to turn the body into stream and pass the stream to send request. But let's stick to what we have right now. Okay, so that's how we send the request. Is there anything that we need to do as well? Yes, it is. Yes, it is. So we have base URL and path, we have method, we have body, and we are missing headers. For headers, there is a method. There is a method on HTTP, and that method is let me check, add header, right? So it's add header, and then you pass the header name and header value. And because our headers is vector, I can do very simple for statement on the request headers, and then add header for each header, which is gonna be h.first and h.second is the value, right? So that's gonna add the headers to the request. And I think this is pretty much it. I'm going to make a simple request now. So HTTPSClient instance is gonna be the next step. We need to create it. Okay, and for that we need a certificates, Wi-Fi manager, and timer. So there's gonna be some includes we need to add. So we need event dispatcher, we need timer, we need not ticker, timer, we need Wi-Fi manager, and we need our HTTPS client. Okay, CertStore is initialized. Now we're going to initialize timer, event dispatcher. I also need to simplify that. So yeah, the next refactoring session is gonna be quite long, I think. Then we need Wi-Fi manager. We need as well 2 constants, SSID and password. So the Wi-Fi network name and password, right? We also need to connect to the internet, but this is all handled already by Wi-Fi manager that is used as a dependency of the HTTPS client. So, oh yeah, there is one more missing, which is the Wi-Fi, which is Wi-Fi multi, right? And we also need Wi-Fi multi. This one. So Wi-Fi multi. This is used by Wi-Fi managers. So we have Wi-Fi multi. Then what else we need? Dispatcher. Then timer and SSID and password. So that is for the Wi-Fi manager. And now finally I can create an instance of HTTPSClient, and this one needs, I think the first one is a CertStore. There is something, oh yeah, there is it. So CertStore Wi-Fi manager, pointer to Wi-Fi manager, so I need to take address and timer. So just 3 dependencies, okay? Okay, so HTTPSClient created, and let's call, let's just call it, right? So what we're gonna do is HTTPSClient dot send request, and that takes the request. So what I can do is to just just pass the request. The second one is the callback function on response that I'm gonna create as a separate function here. I could pass it straight away using the C++ lambda function, but let's just separate it. Let's create the on response separately, because the reason why I'm doing it is because we're gonna have more requests done in this example in a few minutes. So it's good to have like just one method that's gonna read it, right? Hang on, let me just quickly check. std function void response. Okay, so that needs to take a response. So that's gonna be response rest. It's void, and that's what I'm gonna pass. So on response. Great. Okay. The request itself. So the request itself, let me have a look. Maybe I even copy all of those. So we will see what is required to be passed, right? So what is required to be passed is base URL, right? What would be the URL I would like to send a request to? You know what? I'm gonna use the request bin. It is a very common tool. This is a very common tool used. Yeah, let me create public bin. So this is basically going to display any requests that are being made to this URL. Right, so this is more like a debugging tool for working with APIs, with HTTP clients generally. So let me show you. Maybe I give you an example quickly with a curl. So I'm gonna copy this URL, and if I do just curl to that URL, right, that responds with success true, and then we see that request in here. Right, so it's more like a like debugging tool for HTTP clients, and we can basically make sure the ESP8266 HTTPS client works properly, and it's also HTTPS. So as you can see here, the endpoint is HTTPS, so should be fine. Okay, let's go back to the code here. And yeah, so the first argument is gonna be the base URL. This is the URL to the request bin. The second one is gonna be path. I'm just gonna put example here. Then we have method. So HTTP method, and that method is gonna be, let's do post, right? So we have post, then the body, and the body, let's just do a simple JSON. So we have like message, maybe hello from ESP8266, and then some headers. So headers, let's just send maybe one header, make pair, and that header is gonna be X user, let's just call it Thomas, right? So me. Cool. So we got this done. You know what? I'm actually not sure about the method that we're passing here. Let me just quickly go back to this code again. And what kind of method do we pass? Okay, we pass the right method. Okay. Right. So that's what we do. And then on response is gonna be called once everything is done. So once Wi-Fi is connected, clock synchronized, and request finished. And here we should get res error, which is if it's different than null pointer, then that means the request failed with some sort of an error, and we can display this error, and that's gonna be it for our on response. And otherwise, in case of success, which is something we expect to happen, what I want to do is simply again print that out as something like that's gonna be status and response. Maybe let's just do like status and body, like that. And then the status is gonna be the status code, and body, this is a stream at the moment, but we can read this as a string because it's not very big. That's just gonna be this success message. So what we could do is to just use read string. As you remember, I've added that method here, right? So they're just gonna read the string from Wi-Fi client, which is gonna be the response body. Okay, I think this is pretty much it to make that request. One last thing is to add the timer tick here. And let me try to compile it, see if I haven't done any mistakes, which I have done. Let me check. Okay, there's a bunch of errors. So Wi-Fi manager was not declared. Okay, Wi-Fi manager. So that's one thing. And what else is? Oh, I see. Okay. Yeah, this requires C-string. And the last issue is here with the request. Let's see what is it about. Candidate expects 0 arguments but 5 provided. I think let me just go back to HTTPSClient. I try to remove this default value. That might be actually the problem right now, and I try to figure out it later in a different way. Yeah, okay, that works. Yeah, so the last issue was with the default value here. Probably need to turn it into a class or use some sort of a builder at some point. But yeah, for now, let's test it how it is. So now this compiles, and this is something we don't need at the moment. However, as you can see from the consumer, from the developer point of view, on the HTTPS client send request, this is gonna be a bit problematic, right? Because you have to remember what is the order of the arguments that you need to provide the members of the request struct. So ideally there would be some sort of request builder, right? You could do something like let's say like request build, and then you would do things like, you know, method, and the method, right, post or something, and then body, and so on, right? But that's gonna be the next step. Let's just try this. So I'm gonna deploy it. Okay, deployed. And let's see what we get. Right, okay. Certificates read. And now we're waiting for NTP timesync. Okay, that's done. And what we got is post HTTPSClient. Okay, we got back status 200 body success true. And now let's go to the request bin. And yeah, that's correct. We got post request on the example endpoint, example path. Then the body was message hello from ESP8266. And headers, apart from those default headers, we have ex-user Thomas. Great. So that works. That works. Right, but as I said, this is not very convenient interface to work with, because you need to remember the order. And I mean, I guess what we could do, which would be another option, is to create the request first, like that, and then set all of those properties after. But I'm thinking about making it more convenient for the developer to use. And the last step for today is gonna be using sort of a builder pattern to compose this request struct, this request struct, more like this is really a structure, data structure, not really an object. There is not really any specific behavior inside. Right. So what I'm gonna do is just follow an example on the internet. Let me just show you. It is this one, I think. C++ builder pattern with Fluent API. Yes, that's what we want to do. Sort of like this one, right? So the way you can use it, like on this example, we have an email builder, but you see, that's how you do it. So you have like, that's for email. So you from to, and you just continue composing your object, your structure, right? Okay. So let me go back to the code, and we're just gonna do something very similar to it. So here, somewhere before the request, I'm gonna define class called RequestBuilder, and then let me just have a look at this one, and then we have the actual structure, but I'm gonna have to turn it into class. I'm gonna turn it into class. Do I have to though? Maybe I don't even have to turn it. I can just work with a struct, because our case is slightly different. We want to keep those public. So let me create something like a static that's gonna return the RequestBuilder, static RequestBuilder, and I'm gonna call it build. Something like that, and then the RequestBuilder itself. The RequestBuilder itself, what we need is all of those methods and operator. So I'm gonna start from the operator. We need public and private. And here we're gonna need this operator, but obviously that's not gonna be email, that's gonna be request. And here we're just gonna move the request. Maybe let's just call it request, and that request is gonna put here the private, so something like that. And then apart from this operator method, what we need to do is yeah, that's just gonna be pretty straightforward. So that need to return so any of those methods. So like what we have base URL. So I'm gonna create a base URL RequestBuilder. I think this is how it is, right? Yeah, RequestBuilder and base URL. And that's gonna just take this const char u as for the URL, and that's just gonna set this on the request. So that is u, and return this, right? So all of those methods, except for the method, I'm gonna tell you why in a second, but all of those methods I'm just gonna define in this class, so that we have path. So path again, p request path is p, and return this, and the request builder body. This is again, for now, this is const char, but you know, thanks to this request builder, we could actually, when I add the functionality to read the stream, the request stream, I can overload this method, and you know, add possibility to pass the stream instead of const char, or maybe even a string, right? So we can have 3 overloads in total. Body, that's just body equals, why did I put C? It should be something like B, and return this, and headers, right? The last one is headers, and that's gonna be different, right? This is std vector of std per const char, and headers maybe just h, and then it's gonna be request headers equals h, and return this. Right, for the method I'm gonna define a constructor for the request builder. So request builder is gonna require us, upon construction, it's gonna require us to pass HTTP method, right? Because really, without HTTP method, it's not really possible to do anything to make that request, because, like, you know, I could set a default one, but I think better idea is to force the consumer of that builder to pass the method, and that method is going to be set just yeah, hang on, yeah, there it is. So that's just going to be request.method equals m, right? And we don't need to return anything because this is just a constructor, right? So we've got that, and now we have to define the request builder build, and that's going to happen in a similar way it was done with the email builder. So we need something like, one second. So that is email builder. The email builder here is the return type. So we will have request builder, and then there's gonna be request build, because that's how I called it. And it takes HTTP method, and that returns request builder, and request builder again, it requires us to pass that method, right? So I think this is it. Let me try to compile that. Yeah, that is not it. Prototype for request builder, request build does not match any in class request. Is it this because, yeah, this is because of the signature that I need to specify here as well, right? So now if we have that defined, yeah, that's working. and let me show you how to use it. So let's keep this request. That's fine. We're gonna keep it. And we're gonna make another one. I haven't actually tried before to do things simultaneously with the timer, because this is essentially how this is gonna be, but I think that's still gonna be sequence under the hood. So yeah, so now what we need to do is to just pass request and build. That requires the method. So let's just pass something like, maybe this time it's gonna be just get. So we don't specify everything. Or maybe put. I just want to specify. I want to specify everything to see if this is done properly. And then what we have to do is specify base URL. And base URL, I'm gonna keep this one again. So we should see that in the request bin. Then then the second one is gonna be path, but the order is not important now, so we could do headers first or something like that, and that's gonna be maybe test. So path, body, headers. Do we want any headers? We want body, just empty one, and headers, but this time I'm gonna make pair of, I'm gonna pass a header content type, and that content type is gonna be application JSON, very common one to use with REST APIs. Okay, so that's it, and we need a second argument which is gonna be on response. So on response is the second one. Great. Okay, let's see if this works. This might require us to send another request once this is done, so it might not work straight away, but let's give it a go. Let's give it a go anyway. Okay, deployed. And we should see something in a few seconds. Okay, so we've got NTP time synchronization, 2 synchronizations, right? Okay, that's done. So we've got the first one. The first one almost finished. I think it's reading the body. Okay, the body has been read. And the second one to test. I've just realized something. This shouldn't be get anymore. Right? Small sort of typo kind of issue. So yeah, let's change this to method, right? That should be method. And that should be also here, that should be method. Is that correct? Yeah, I think it is. Let me just try to compile that. But yeah, anyway. So that worked. Let's see how this looks like in the request bin. Okay, yeah, we've got the example one. So that's just state as it was before. No changes to this request. And the put one, what we've got is a content type application JSON, and this is the body. The endpoint is test. So that works correctly. That works correctly. Yeah, I'm not gonna be testing it again with those changes on the... Yeah, let me just show you. So yeah, I'm not really gonna test it correctly to just check if this is different, because I'm pretty sure it is. However, the code example I'm gonna share with you is going to have that issue fixed, right? For tomorrow, I am planning to do an upload. So with HTTPSClient, we're gonna try to upload a file. I'm thinking about doing it with S3 pre-signed upload URL. So, nice working with the cloud. But yeah, that's gonna happen tomorrow. For today, this is it. Thanks for watching. If you have any questions regarding the code, the solution I have built today, or you want me to make a video about a specific subject, or if you want me to make a specific project, please let me know in the comments. If you like the video and you are interested in this type of content, I suggest hitting that subscribe button so you will stay up to date with my channel. Thanks for watching and bye!